Well, we're off to another day of implicit differentiation. Today we're really going to focus on some AP type questions. So just take your time and remember, pause it, rewind it, come prepared for class tomorrow. All right, notice we have implicit differentiation because again we have our y's and x's. So our question is find dy dx, of course. Okay, so let's just start by reading this left-hand side. This says the sine of xy. Well, anytime I say of, that's our chain rule. So here's my outside, here's my inside. Derivative of the outside, keep the inside, times the derivative of the inside. So notice what my inside is. It's xy, and if I read that, that says x times y. So I just want to be clear, my inside is a product rule. So I'm going to say it's the first term, derivative of the second, plus the second term, derivative of the first. Okay, then I have that nice equal sign. Now notice this quantity is the quantity x plus y to the fourth. So this is my inside and this is my outside. So I'm going to say derivative of the outside, keep the inside. Lots of self-talk. Raised to the third. Now I need the derivative of the inside, and this inside is x plus y, so its derivative is 1 plus dy dx. Now at this point, this looks pretty ugly, but I want you to understand your calculus is done. Calculus is not the hard part. The hard part is cleaning it up with our basic algebra. So if I showed you an example like 4 times the quantity x plus y, I don't think that would bother you. I think you would say to clean this up, I would take that 4 and distribute it. Well, believe it or not, this is the exact same problem. It just looks uglier. Instead of a 4 out front, I have cos xy. And then I still have something plus something right here. This term plus this term. So all I'm doing is I'm taking this term out front and distributing it to both. So let's cleanly write that. I'm going to say that that is x dy dx, I'm pulling that out front, times cosine of xy. Okay, I'm just multiplying those, then I have a plus sign. Now I'll distribute that through. Y cosine of xy. Notice nobody else gets to come inside this parenthesis except xy. Okay? Equals, would you agree this is the same thing? Again, it's ugly, but it's the same thing. It's this one quantity in front times this quantity here. So I'm just going to take this junk in front, this ugly stuff, and multiply it by this term and this term. So I'm going to say equals, try to squeeze it in here, 4 times the quantity x plus y cubed plus 4 times the quantity x plus y cubed dy dx. So again, I just took this junk in front and distributed, took this junk in front and distributed. Now remember the goal with implicit. Anybody that has a dy dx stays on one side, anybody else boots to the other. So this whole term that has the dy dx, that's going to stay. So x dy dx cosine of xy. This term doesn't, so I'm going to kick him out. That term's going to stay on this side, and this term needs to move this way because it has the dy dx. So I'm going to subtract 4x plus y cubed dy dx equals, let's say 4 times x plus y cubed, and I'm going to subtract that y cosine of xy. Alright, lastly, I'm almost done. I'm just going to factor out that dy dx. My goal is to get it by itself. Okay, and you should be pausing, making sure you can do that on your own. And then lastly, I'll divide this term over to the other side. So as I clean it up, I get dy dx equals 4 times the quantity x plus y cubed minus y cosine of xy all over x cosine of xy minus 4x plus y cubed. Now, just remember, your gut might tell you you want to cancel these, but you can't cancel because of this minus sign. So believe it or not, that is my final answer, and that's my derivative. Now remember, you could have a negative of this, positive here, positive here, and be equivalent. But that's it. Our next question is something that we would see on our AP exam in the free response section, the non-multiple choice section. So there's two parts to it. Part A, consider the given curve, and A, find all points. Okay, watch that word points. That's implying there could be many, if any, at which the graph of the equation has a horizontal tangent line. And then write the equation of each horizontal tangent line. Alright, so basically we're looking for keywords, and we're just going to pull out what's important to us. This is the description, a horizontal tangent line. Now, you don't have to memorize anything. Just draw yourself a horizontal tangent line. And ask yourself, what do you know about it? Well, remember, calculus, we've been talking about derivatives, and derivatives just represent slope. What do you know about the slope of a horizontal line? Well, we should all know it has a slope of 0. So what the question is really asking you to do, it's saying set your derivative, or your slope, equal to 0, and solve. So that's what we're going to do. So at this point, okay, in order for us to be successful, pause it, take the derivative, and see if it matches with mine. So here's a snapshot of my work and my derivative. Now you'll notice one thing, that each of these numbers here is divisible by 2, and since everybody is, I can simplify this equation even further, which is probably to my benefit. I can divide every single one of those numbers by 2. I'm going to say 4 minus 4x all over y plus 2. And there is my derivative. Now, we said a horizontal tangent line meant set your derivative equal to 0. So I'm going to say 4 minus 4x all over y plus 2 equals 0. Now, sometimes this bothers people, but think about this. If you have a fraction and it's equal to 0, and here's the important part, and again, you don't have to memorize it, think it through. If your fraction equals 0, was your 0 on the top of your fraction, or was your 0 on the bottom? Hopefully you're saying 0 divided by any number is 0. So that implies my 0 is on the top. So I'm really just setting my numerator equal to 0. So I'm going to say 4 minus 4x equals 0. Quickly solve for x, and x equals 1. Now, we're not done there. Remember the question said, find any points where we have horizontal tangent lines. Points imply you have an x and a y. So I know my x value is 1. I need to go get my y value. And we're always going to plug things back into the original. So that original equation was 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. Plug my 1 in, and I get 4 plus y squared minus 8 plus 4y plus 4. So as I continue to solve that, nice easy algebra, I get y squared plus 4y. 4 minus 8 is negative 4 plus 4 is 0, equals 0. Nice little GCF, I can pull out a y, and I get y plus 4. Tee it up, and I get y equals 0, and y equals negative 4. Now wait a minute, I had one x value and two y values. So what does that imply? Well, that implies there are 2 points. When x was equal to 1, this is when we substituted x equals 1 in, we got a y value of 0 and a y value of negative 4. So my 2 points are 1, 0 and 1, negative 4. So what does that look like? Well, maybe it looks like a circle. Whoops. Let me draw a better one for you. And at the point 1, 0, you have a horizontal tangent line, and at the point 1, negative 4, you have a horizontal tangent line. And the last part there said, write the equation of the horizontal tangent line. Well, this equation would be y equals 0, and this equation would be y equals negative 4. Part B, find all points, and again that's plural, if any, so there may be none, at which the graph of the equation has a vertical tangent line. So there's my key, vertical tangent line. So you don't have to memorize anything. Draw yourself a vertical tangent line or vertical line and ask yourself, what do you know about it? Remember, this is calculus, so I want to know about its slope. The slope of a vertical line does not exist. Okay? Now, what does that mean mathematically? Well, that means you tried to divide by what number? If you get it does not exist, you tried to divide by 0. So any number in the world divided by 0 does not exist. So basically, I need to set my slope and my denominator equal to 0. Now, I don't have to do too much algebra because we already found the slope from part A, so I'm just reusing that. That was 4 minus 4x all over y plus 2. And again, if it doesn't exist, that means the bottom equals 0. So I've got y plus 2 equals 0, y equals negative 2. Now remember, we're not done there. The question wanted points. We only have a y value. So we need x. And anytime you're looking for the other variable, you plug it into the original. So as I carefully plug negative 2 into y, I get 4x squared plus 4 minus 8x minus 8 plus 4. So that's 4x squared minus 8x. Those all cancel, equals 0. I can pull out a 4x, and I'm left with x minus 2. If I t that up, of course, equals 0. I get 4x equals 0, therefore x equals 0 itself. X minus 2 equals 0, x equals 2. Now what does that tell me? I got two x values. Well, that implies that I have two vertical tangents. My x value is 0 and my y value is negative 2. Remember, we got that up here. Or my x value could be 2 and my y value is still negative 2. So I have 2 points where I have vertical tangents. So let's picture what that looks like. At 0, negative 2, you have a vertical tangent line. And at 2, negative 2, you have a vertical tangent line. So again, perhaps your graph looks maybe circular and you can picture 2 vertical tangent lines there. The last piece says write the equation of each of those lines. Well, notice we cross the x-axis, so I would say it's x equals 0 and x equals 2. Alright, we're going to have one more question that'll have several parts to it. Another AP style question that we'll see in our free response. Consider the curve in the xy plane given by that function. A, find all the points on the curve with an x coordinate of 3. So notice again, they want you to find a point. So that means you need an x and a y. Well, they tell you the x value is 3. Of course, you just need to find the y value. So you don't need any calculus, you're just finding y. So I'm going to replace all my x's with 3. So I'm going to say 3 squared is 9 minus, I'm just plugging them in here in the original, minus 3y equals y squared minus 1. Set one side equal to 0, so that's y squared plus 3y minus 10. I'll factor y plus 5, y minus 2 equals 0. Tee it up. I get y equals negative 5 and y equals 2. So it does say points, implying there's more than one. So here they are. When my x value is 3, my y value could be negative 5. And when my x value is 3, my y value could be 2. So there's the answer to part A. That's simple. This time we'll attack B. Write the equation of the lines tangent to the curve at the points found in part A. Well, let's just recall that I had the point 3, negative 5 and the point 3, 2. So if you have 2 points, what that implies is that you have to write 2 tangent lines, one for each point. Each point will have a separate slope. So really, the only thing I'm missing is when I want to write the equation of a line, I say to myself, I need a point and a slope. I have the points. All I need is the slopes. And slope, of course, means take this guy's derivative. So again, at this point, you need to pause it and take the derivative on your own. That's how we're going to get the most out of this flipped class. Pause it and see if yours matches with mine. So hopefully your derivative matches mine. Remember, this says x times y, so we did product. We kept the negative out front. There's our nice easy product. And remember, you can either have this version or this version, depending upon which way you solved. Okay, at this point, I need to use that slope and I need to use the 2 points I found. And for my first point, which we said was 3, negative 5, I just need the slope at this point. So I'm going to take my slope formula and I'm going to plug in the 3 and the negative 5. So I have 5 minus 6 all over negative 3 plus 10. So that gets me a negative 1 over 7, which is incorrect because that was a negative 5. So I'm going to go with negative 11 over 7. Hopefully you caught that on me. And the equation of that tangent line then is y plus 5 equals negative 11 over 7 times x minus 3. Now I have to write one more because it said write the equation for each tangent line. So my other point was 3, 2. And this one's going to have a different slope because I'm plugging different x and y values in. So I'm going to say that's 2 minus 6 all over negative 3 minus 4. That gets me a negative 4 over negative 7, which is equivalent to 4/7. So when I write this equation, I'm going to say that's y minus 2 equals 4/7 times x minus 3. And there you have it. There's the equation of your two tangent lines, different slopes at different points. So part C, find all the points, so again we're finding points x and y, on the curve who has a slope of 4/7. So this couldn't get more obvious. They're telling you set your slope equal to 4/7. So again, we already found all this work in the previous part, so I'm just going to take my slope. So that was, I believe, negative 2x plus y, depending upon which version you're going with, all over negative 2y minus x, and just set it equal to 4/7. And again, you shouldn't have to guess at it. It says slope, so that's your derivative, equals that. And my goal is to find the x and y values. So I don't know what your gut says, but mine surely says cross multiply when I see something like this. So I'm going to say that's negative 14x plus 7y equals negative 8y minus 4x. As I clean that up, I get, let's see, 15y equals 10x. Now basically I have to solve for x or y, and it really doesn't matter which one I solve for. I'm going to solve for x this time, and like I said, it doesn't matter. 15y over 10, divide both out, and I can say that's 3y over 2 is equal to x. Now, does that look like a point to you? If I said x equals 3y over 2, I wouldn't know how to plot that. So I'm not done. I basically need to take what I got for x, because it's not a number, substitute it into the original. Have you found a common theme yet? We're always going back to the original. So there's my original, and I'm substituting this 3y over 2 in for x, so nice and carefully, 3y over 2 squared minus 3y over 2 times y equals y squared minus 1. That gets me, let's see, 9y squared over 4 minus 3 over 2y squared equals y squared minus 1. Now, I'm not a particular fan of all these fractions, so I'm going to kill them, and I can do that because I have that equal sign here. And I'm going to say my common denominator is 4, and if I multiply each term by a 4, I should kill all the fractions. And remember, we do it to every term to balance it out. So that gets me 9y squared minus 6y squared equals 4y squared minus 4. And as I clean that up, let's see, that's 3y squared equals 4y squared minus 4. Oh, I'm going to subtract that over, so I get 0 equals y squared minus 4. And if I factor that, I get y plus 2, y minus 2. So y equals plus and minus 2. Now, because I got two y values, that just again tells me there are 2 points where I have a slope of 4/7. The y value is positive 2, and the y value is negative 2. Now, I'm just going to pick the nicest equation I have to substitute in, and if you look back here, remember we had x equals 3y over 2? I'm going to use that and figure out what my x value is. So we had x equals 3y over 2. If I plug in a positive 2, I get x equals 3. And if I plug in a negative 2, I get x equals negative 3. So there you have it. That is the 2 points where I have a slope of 4/7. Well, you've seen 2 different types of AP problems, and we're going to tackle some more tomorrow. So good luck.